Here we go. It is time for topic number 33, finding extrema without the graphs. So the last few we've talked about finding global and local extrema. Remember, global being the highest and the lowest minimums and maximums, and then our local just being any minimum or maximum look in place. Today we're going to talk about how we find them when we don't have the graph, okay? In order to talk about that, ironically, we're going to look at a graph. So when we look at a graph, we can hopefully by now pick out our local minimums and maximums, right? So if I'm looking here, I know that this is a maximum, my hill shape. Then down here, I know that this is a minimum, and then I know that here is a maximum, okay? And I actually shouldn't have drawn arrows here because we're gonna talk about them on closed intervals. Closed interval meaning that the graph actually stops at a certain place, okay? So I'm gonna actually change these into points here, okay? Now, we are going to talk about what happens when we have an equation and how we can find our local minimums and maximums, okay? So we're in the topic of derivatives right now, and remember the derivative means the slope of the tangent line. So I'm gonna draw a tangent line here on all of my minimums and maximums because all of your tangent lines of minimums and maximums, or extrema, are gonna have something in common, right? And hopefully you can see right now what they have in common. They are all flat horizontal lines, right? So if they're flat horizontal lines, that means that their slope at this point must equal to 0, right? So in order to find where my maximum and minimums are, I can do that without the graph if I just think about all of the places where my derivative is equal to 0, or where my tangent line is a horizontal line, okay? We call these places where the derivative equals 0, we call those critical numbers, okay? So all the places where the derivative equals 0, or where we have a horizontal tangent line, that means we have a minimum or a maximum present, and we call those critical numbers, okay? So now let's move over to our actual note card here. And that's what this says. So it says critical numbers. Let f be defined at c. If f prime of c equals 0, right? And we know that that means that the slope equals 0, okay? We have a tangent that is, sorry, I wrote that in the wrong order, that was weird. A horizontal tangent, right? Those all mean the same thing. So if we have the f prime of c is equal to 0, that means that the slope is 0, or the horizontal tangent, okay? Or if f prime is undefined at c. What does undefined mean? Undefined means that the denominator is 0, right? We're dividing by 0, okay? So either of those places are gonna be critical numbers for us. To find the critical point, find the y value of the function at c or f of c, okay? So here's how we do this. We are going to use this kind of table here where we're gonna list all of our endpoints because our endpoints could possibly be absolute. Remember, our absolute we find inside our interval or at our endpoints. And then we wanna check our critical numbers. Okay, so let's skip down to number 1. We'll go through the steps as we go here. So for number 1, it says determine the critical points of g of x equals 2x cubed plus 3x squared minus 12x minus 1. I'm gonna move over and do this on the whiteboard, but hopefully you will have room there. If not, just copy it into your notebooks. Okay, so again, we said that we had to determine the critical points for, make sure I'm in the window here, 2x cubed, uh-oh, am I dying? I'm not dying, don't worry, I'm in perfect health, but my marker is dying. 2x cubed plus 3x squared minus 12x minus 1. Okay, so we want to find where the critical points equal, or sorry, the critical points of this. Remember, a critical point is where the derivative equals 0. So first, I have to find the derivative of this. So this, we had called this g of x, so g prime of x is equal to, power rule, 6, come on marker, don't die, 6x squared plus 6x minus 12, and then that minus 1 goes away. Yes, I did that right. It's hard not having you guys here to correct me. Like, I have to do this all on my own. Okay, now we want that to equal 0. Okay, so throw it back to Algebra 2. We need to factor this. There is a greatest common factor that I can take out that will make my life a lot easier. So I'm going to divide this by 6, and then have x, and then minus 2 equals 0, and I'm going to factor it. So I have x. I want two things that multiply to be -2, add to be +1. So I know I'm going to need a 2 and a 1, and I want it to be positive, so the bigger number has to be positive, and then minus, and that equals 0. Okay? Now that means that x equals -2, and that x equals +1. So those are my critical numbers. This is a polynomial function, so nothing can possibly make it undefined. There's no denominator in it, okay? So I don't need to think about that. So now I am going to make my chart here. So remember, I want to look for my possible x's are I want my endpoints. Oops, sorry, that's so out of the window. There you go. I want my endpoints, and then I want my critical points. Okay, and then I have to figure out what the y value is going to be. So let's first list our endpoints. Okay, this one, did it give us endpoints for number 1? It did not, so we actually don't have endpoints, so we're not going to test those on this one, on this example. But we did have critical points, which again were my numbers over here, -2 and 1. So I'm going to list -2 and 1. Okay. Then I want my y values. My y values, all I'm going to do is plug them in to my original equation. So I want to plug in -2 here. So I would have 2 times -2 cubed plus 3 times -2 squared minus 12 times -2 minus 1. So notice I'm not plugging it into the derivative. I don't care what the slope is. I want the output, the y value. So I would have, being very careful with my negatives here, a negative cubed is a negative still, so I would have 2 times -8, then I would have plus 3 times 4, plus 24 minus 1, and I would get then -16 plus 12 plus 24 minus 1. I would then have, I'm going to add these first, 36 minus 16, because it's easier for my brain. So 36 minus 16 is 20, minus 1 is 19. So that is a possible there. Okay, and now we're going to plug in 1, which is going to be much easier for us than that -2. All right, so looking at our, whoops, there it is, original equation, we would have 2 plus 3, it's 5, minus 12 is -7, minus 1 is -8. It's very nerve-wracking to do that math when I don't have anyone to check myself. What in the world? How did that die? Ugh. Okay, -8, we're trying to switch to blue. There you go. So now, those are our only options because again, we didn't have endpoints. So we're going to think about which one is the minimum, which one's the maximum. Pretty obvious in this case that this -8 would be my minimum and that 19 would be my maximum. Oh, there you go, maximum. All right, on to number 2. So for number 2, read it carefully. It says, for f prime of x. So look at that, that's so, oh wait, where is it? Wait. There you go. For f prime of x equals cosine blah, 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 blah. They are so kind to us. Look at that. They already gave us the derivative. So we do not need to find the derivative. It already gave it to us. And it says how many critical values. So it actually doesn't really care what they are. And this is a calculator question. So I'm going to show you a trick. Okay. So remember that for critical values, we want f prime of x, which they give us, to be equal to 0.